the way it works is it's called a spring reverb because it's a spring in a pan. And what happens is the signal is coupled into this spring, and this spring kind of transmits and receives from the pan. So the signal is bouncing around in there, and it creates a sound that sounds like you're in a hall or a chamber.
So yeah, one time I like dropped the boom, or like put it down and turn it on, so that's...
Yes, and yeah, if you kick the amp, you will hit the spring into the pan. You'll get that distinctive sound. The funny thing is, Dan Electro, I mentioned before, they came out with a couple of big pedals at one point. One was called the Spring King, and it was a real tube reverb inside the pedal. And it had a foot switch to turn on and off, and it had a little rubber pad they called the kick pad. So you could hit the pedal and get that noise. It was just, you know, one of these crazy things. Perfect marketing, I love it. So that's what the reverb is. So yeah, the last week I brought in my Vibra amp, which had tremolo. This Mesa Boogie has reverb. Now the other thing to note about this is a 2-channel amplifier, and I use this 2-channel sometimes applied differently. With a lot of the older Fender designs, you had 2 different inputs. And you can plug into the normal channel or the vibrato channel, and they usually had similar things. Sometimes the tone stacks were a little different. In this case, the vibrato channel has a tremolo applied to it. The normal does not. But often you had bright channel versus normal, and they had different things. And then with certain Marshalls, you actually had ones where you have gain stages, where you, like, if you plugged into one input, you'd get 3 gain stages. If you plugged into the input, you get 2 gain stages. You short circuit it. Then you got to more modern ones. A lot of times now, amplifiers can be called 2-channel if they're channel switching. And that's what this Boogie will do, where the foot switch will switch between 2 different gain structures. So you have one input you plug into, but you hit the button to get different channels. And part of this comes from the evolution of where tube amps came from, what they were originally designed for. Originally, they were designed with multiple inputs because they were expected to take multiple instruments. So like I have an old Premier amp from the 60s that had 3 instrument inputs. They all went to the same volume. And then they had 1 mic input. You know, just like I said, I think it was a separate volume even, I can't remember. So it was one of these weird things that they expected people to plug into one amplifier. And you also can see that, so many interesting evolution stuff. You know, I love the history of this stuff. If you look at older amps, right, this is a fairly modern amp. You got a speaker, you got knobs above it. You look at like a little before, sometimes you see the knobs are on top. And then you look at the really early amps, the knobs are on the back. And the idea was that this amp would be in front of you. You know, that you were on a bandstand or something, the amp would be in front of you, and there would be the knobs on top. So my Premier has the knobs on the back top. You know, that's what the intended use was. And it's kind of interesting to see that evolution of, you know, not only the guts of the amp, but how things were changed. You know, and then you got fun dead ends, like Epiphone once had a really wild one where the amp had no knobs on it. They had routed all the knobs to the guitar. It had a matching guitar. So all your normal amplifier controls were on the guitar. It was crazy. I saw one recently. It really tripped to see real
So they had like a special cable built for it, I guess?
Yeah, everything. This was 60s or something. So it was crazy. Yeah, it's pretty cool. Okay, so let's dig in. Power supply. Okay, like I said, everything is built around this power supply transformer. We've got high voltage section, low voltage section. The rectification, like I said, tube or solid state. This one, obviously solid state. Never needs to be changed. That is one of the benefits of solid state. Higher voltages, which is more headroom. So it all depends what you're looking for. You know, if you're looking for a lot of headroom and a lot of clean signal, maybe you want the solid state. If you like that distorted sound, then maybe the sag is better. The interesting things to note here, we've got, you know, AC. So if we go left to right, we've got AC power. This amp has an extra receptacle on the back, which is kind of cool. We've got this capacitor here, which I don't think I've referenced here, but I'll definitely talk about later. That's the ground switch. You got a fuse, and then you got the main power switch. And then on this side, you've got the high voltage, you've got some caps, which, you know, are filter caps that give you your cleaner DC, and then you have a standby switch. So what the standby switch really does is, the on switch powers up the transformer and heats up the tubes. That's key. You want to do anything to your tubes until they're warm. And then the standby switch is what, you're generating high voltage, the standby switch is what connects the high voltage to the rest of the circuit. Okay? So when you power up a tube amp, what you want to do is you want to turn it on, wait 30 seconds for your tube to get hot, and then turn on flip the standby to play. And that allows the high voltages to come up at a time when the tubes warm up that they're emitting electrons. Because if you turn on the high voltage too soon, you'll rip the electrons out of the cathode and you'll damage the tubes. Okay, now this one, like I said, you've got your rectified signal, you've got your filter capacitors. This one's actually got a choke too.
Which the filter capacitors, they just smooth out the waveform, right?
They smooth out the waveform.
Like a lower, smaller ripple.
Right,
And
exactly.
And then the choke, what's the choke? The choke?
Same thing, right? A choke is an inductor.
Yeah.
It's a current limiter. So the parallel capacitor, you know, parallel from the power supply to ground, its job is to smooth out the voltage. Well, the choke is inline. Its job is to smooth out the current.
Mm-hmm.
So combined, they form a more, you know, second order filter. It's really the two ways of looking at it, right? And then what's interesting is after, if you look at that, you've got a choke, and then a capacitor, resistor, capacitor, resistor, capacitor. So what this is actually a step-down network where each point, B, C, and D, are the plate voltages for different tubes. Okay? So B is the plate voltage for the power end tube. They always use the highest voltage. And then C may be, actually look at, it's hard to see what the voltages are here.
405.
Yeah.
30 something.
That's probably used for the screen grid on the tube. Let's see. I don't know if I scroll back up if I can see. Because it is so B. So that's tied to the. Oh, actually no. Interesting here. So the highest voltage goes to the output, the plate. And usually when you look at power supply on the plate voltage, it almost always goes into the center tap of the output transformer. Okay, so the plate voltage goes through here. There's negligible DC loss to the transformer, and then that supplies the plate. So this first step down supplies the, I think I forget, it's the screen or suppressor grid, but one of the grids is held at almost a plate voltage. So that's what this first step down is for. And then this one, the C, you can see comes in here, and that gives you a plate for the phase inverters. And then B is used, should be used further down here for the input tubes. Oh yeah, it's tied directly. B goes over to here for the input tubes. So that's how the different voltages that you needed are generated. They're basically a step, a voltage divider network. And in this case, remember the voltage divider is this series resistance and the draw of the tubes. So it's not like a straightforward voltage divider that you would expect, where it looks like this, and then you would take that off. This is actually the draw. So this is where I'm saying that how this power supply stuff is very dynamic. If that draw changes for any reason, you can have problems. Okay, so now we're going to blow up the preamplifier section. So again, like I mentioned, traditionally Fender had 2 input channels, and new ones are switching. This amp originally used a 7025. That is, I don't remember the exact spec, but it's akin to a 12AX7. It's a small mini 9-pin medium or high view triode. First gain stage boosts the incoming signal to drive the passive tone network. The problem with the passive tone stack is if you just try to drive it, there's a lot of loss in there, right? You're talking about 3 cascaded passive filters. There's a lot of loss in that. So you need